On February 18th, 2021, we were greeted with footage that to me is very unique. What we are seeing here is not our sky here on planet Earth. It is the sky of the planet Mars. When I first saw this, I was instilled with a sense of awe that for the first time in my life, I was watching high-definition footage recorded not here on my home planet, but from another planet entirely. Second only to Earth, Mars is certainly the most explored planet in our solar system. There are several reasons for this, but I believe the most prominent one is because in its past, it may very well have been much like Earth. Now, here on our planet, all forms of life need water to survive. This is why much of our search for evidence of the life on Mars focuses on areas where liquid water may once have been stable. In fact, data from multiple NASA Mars missions suggest the presence of liquid water just below the surface in some rare places. There is also a chance of water being locked in ice at the Martian poles, much like what we think the Moon might have at its poles. Even if it existed in the past, though, life on the surface of Mars is very unlikely, because it no longer has a magnetosphere and has also lost most of its atmosphere. So there is no air to breathe, nor protection from cosmic radiation for any surface dweller to grow and thrive. What about underground, though? We know here on Earth that there are life forms that can exist and thrive deep in the ocean, where no sunlight can reach. Life forms like these gain their energy from chemical and geothermal sources that vent out into the water. This is what brings us to the Mars Exploration Program, which is a long-term effort by NASA to explore the planet Mars. This program has been helping us to study Mars since it first convened in 1999. The program has also had many successful missions, some of which are still operating. Today, we will cover the story so far of the Mars 2020 rover, also known as Perseverance. Perseverance is the fifth rover NASA has landed on Mars. A big advantage that rovers have over things like stationary landers, such as InSight, is that they are mobile. They can drive into craters, up slopes and along sand dunes, and just the ability to change locations really allows us to more fully explore the planet. In December of 2012, at the fall meeting of the American Geophysical Union in San Francisco, the Mars 2020 mission was announced by NASA. The design of this mission's rover, Perseverance, is derived from its predecessor, the Curiosity rover. So, in many ways, it is following in the footsteps of its predecessor. This was helpful to us as it could use many components that had already been fabricated and tested. These would be paired with new scientific instruments and a core drill. In 2014, NASA announced the full suite of instruments that would make up the rover's payload. This decision-making process took the team 6 or so years to complete, and we will come back to this equipment that's on the rover later in the video. The rover was built by NASA's Jet Propulsion Laboratory in a process that took about 7 to 8 years, being started in 2013 and leaving JPL in 2020 ready for launch. During this time, there was one more hurdle to overcome that I would like to touch on. That is the landing spot for the rover. While they can move, it is not fast by any means. So it is still important to land the rover at or near the site we want to explore. This turned out to be a multi-year process where a whole group of experts got together to figure out where the best spot for the rover to go was. For this, they had to consider the science goals of the mission. In the case of Perseverance, they wanted a location that may have supported life in the past. In 2018, it was announced that Jezero crater had been selected as the destination for Perseverance. Jezero crater is an ancient lake bed full of spots scientists want to study. Some examples being cliffs and rocks that may have been eroded away in the past by flowing water, potentially leaving behind signs of life. With the planning and building completed, the fateful day arrived. It was time to launch the Perseverance rover. The date was July 30th, 2020. Amidst the added challenge of the COVID-19 pandemic, Perseverance successfully launched from Cape Canaveral Air Force Base in Florida, atop a ULA Atlas V rocket, officially beginning its journey to our red neighbor Mars. It would travel through space for 7 months to make this trip, arriving on February 18th, 2021. While everything about this process is impressive, the entry, descent, and landing to me is just a breathtaking feat of engineering. Moving at 12,100 miles per hour, or 5,400 meters per second, the spacecraft first sheds its cruise stage as it enters the atmosphere. It is at this point that, with the help of the heat shield and basically through aerobraking, the rover and descent module begin to slow down. Thrusters are fired to help slow the spin of the spacecraft and to keep the heat shield facing the correct direction. At around 12 kilometers from the surface of Mars, the large parachute was deployed. You may notice some strange markings here in orange and white. This helps scientists with the orientation of the parachute, but it also comes with a secret message: Dare Mighty Things, which is the motto of NASA's Jet Propulsion Laboratory. With this, we can see JPL's GPS coordinates along the outside. With the parachute deployed, deceleration continued to a velocity closer to 440 meters per second. Following this, the heat shield was released, exposing Perseverance to the Martian atmosphere for the first time. This allowed both the radar and cameras to get their first look at the surface of the planet. By now, the velocity had slowed even more to 145 meters per second and at around 10 kilometers high. As the descent continued, the rover scanned the ground to find and lock onto its landing position. Alongside the parachute, retro rockets were fired to keep slowing Perseverance down, as the Martian atmosphere is just too thin for the parachute alone. The slowing continued until the rover was no longer descending, stopping at about 20 meters above the surface, and it was at this point, while hovering, that the rover was lowered gently to the surface by something known as the sky crane. Super cool stuff right here. Once the rover touched down safely, the sky crane detached itself and flew away to crash at a safe distance from the rover. And it is now that Perseverance is safely on Mars and ready to start exploring. How exactly will the rover help us to study and explore Mars, though? The answer, primarily through its science instruments and accompanying hardware. Let's go ahead and cover these now. Photos and even sometimes video can be an important tool for us when investigating places we ourselves cannot go. This is even more true when they are paired with other types of detectors such as spectrographs. And so, I present the rover's cameras. And we're going to start here with Mastcam-Z. This is the mast-mounted camera system of the Perseverance rover. Its primary job is to take high-definition video, panoramic color and 3D images of the surface of Mars and features in its atmosphere. It is also equipped with a zoom lens to magnify targets. The pictures we have been seeing so far are all taken by Mastcam Z. Next, we have SuperCam. This instrument examines rocks and soils with a camera laser and with spectrometers. This allows it to seek chemical materials that may be related to past life on Mars. It can identify the chemical and mineral makeup of areas on Mars as small as a pencil point, all from a distance of more than 20 feet or 7 meters away. It is located on the head of the rover's mast, seen here. This is an image taken by SuperCam. It contains 2 images that were put together as a mosaic. Then we have Sherlock, which stands for Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. What a mouthful. This instrument is mounted on the rover's arm, and it helps us to identify organics and minerals that have been altered by watery environments and as such may be signs of past microbial life. It does this using specialized cameras, spectrometers, and a laser. It is assisted by an instrument called Watson, which is a color camera for taking close-up images of rock grains and surface textures. Here are a couple of photos taken by the Watson camera. The next science instrument I would like to go over is known as Pixel, or the Planetary Instrument for X-ray Lithochemistry. Pixel also aids us in the search for signs of past microbial life, but it does this using a spectrometer that detects X-rays, that and a camera that can take super close-up pictures of rock and soil textures. It can see features as small as a grain of salt. Like Earth, Mars has its own weather. Granted, it is much milder. Even so, it is helpful for the rover to be able to detect and monitor weather patterns and dust. You might be wondering, though, how exactly does it do this? Enter the environmental sensors. The first of which is known as MEDA, MEDA, or the Mars Environmental Dynamics Analyzer. This instrument makes weather measurements including wind speed and direction, temperature and humidity, and it also measures the amount and size of dust particles in the Martian atmosphere. We also have RIMFAX, RIMFAX, or Radar Imager for Mars Subsurface Experiment. This one helps us to study geologic features under the surface using a ground-penetrating radar. We one day do want to visit Mars ourselves, not only with rovers, but with human astronauts. While there are many challenges we must face for this, a big one is oxygen. It would be very difficult or just not possible to bring the needed oxygen with us. But what if we could make it there? This is what MOXIE is helping us to study. This is the Mars Oxygen In Situ Resource Utilization Experiment. What this does is take in the Martian carbon dioxide atmosphere and then using it to produce oxygen. While the quantity it's making is rather low, at 1 hour of oxygen per time that it's run, it's showing us that a similar experiment on a larger scale could really help us breathe in habitats on Mars. Now, it is great that we can do some form of studying directly on Mars. Unfortunately, we are limited on what we can accomplish with a mobile laboratory like Perseverance alone. This brings us to one of, if not its primary functions, sample collection. Using Sherlock and Watson, scientists study and determine a point of interest for the rover to sample. Then it uses its drill to take a core sample from the rock or area studied. At the same time, the sample ends up in one of the rover's sample tubes. Different drill bits are available for these core samples depending on what is needed. All of these are stored in the rover's belly, along with a small robotic arm or lab assistant that takes in the sample tubes from the big arm and gets them to the needed spot. This part of the rover also holds the 43 sample tubes that are available to be filled. Along with these tubes, the rover also carries 5 witness tubes. You see, Perseverance must meet extraordinary cleanliness requirements to avoid contaminating the Martian samples it is taking. No matter how hard we try to clean the rover before sending it off, it is still possible that contaminants may have made it there from Earth. These witness tubes help achieve hitting those cleanliness standards, as they are preloaded with various materials that can capture molecular and particulate contaminants. Some examples of these include gases that may be released or outgassed from materials on the rover, chemical remnants from the firing of the landing propulsion systems, and any other earthly organic or inorganic material that may have just arrived on Mars with the rover. With the storage and protections in place, once the core sample is collected and in the tube, it is transferred back to the rover's belly and is handed off to the lab assistant. It is then moved to the inspection and sealing stations. Once the tube is hermetically sealed, nothing can enter or leave it. The tubes remain stored in the rover's belly. However, it would not do to keep all our eggs in one basket, and not every sample is kept with the rover. Some of them are deposited onto the Martian surface in what is known as cache depots. These locations are well documented by local landmarks and precise coordinates from orbital measurements. These samples won't move either. Now, you might be wondering, what is the purpose of leaving behind samples like this in these various cache depots? They would be used as part of the Mars sample return mission, which to me is the most ambitious project ever proposed, and would without a doubt be a first of its kind if successful. This would be a multi-staged project, starting of course with the cache depots already left behind for us by Perseverance. We would then fly out to Mars a sample retrieval lander and an Earth return orbiter. The lander would first descend to the surface of Mars, either near Perseverance or at a predetermined spot. The rover will either directly deliver the samples, or the lander will be equipped with sample recovery helicopters that will fly and retrieve the samples to bring them to the lander. Something we now know is possible due to the Ingenuity helicopter. Once at the lander, the sample canister will be loaded into the Mars Ascent Vehicle, a small rocket that the lander can assist in launching off the surface of Mars. This would be the first time a rocket was ever launched from another planet. The Ascent Vehicle would then bring the canister up to space, before ejecting the sample canister for the Earth return orbiter to pick up. The orbiter would carry the sample canister back to Earth, before ejecting it for us to collect and study here. This would be huge because, as I mentioned earlier, we would gain the ability to study the samples here on Earth with equipment and techniques that we simply could not fly to another planet. Meaning I really think we could learn much more about the past of Mars than we would be able to without doing this. You might recall that I mentioned a sample recovery helicopter for the return mission, and Perseverance had something that is like a precursor to this in its companion, the Ingenuity Helicopter. This historic piece of technology was a tech demo intended to prove that powered, controlled flight is possible in the thin Mars atmosphere. And boy, did Ingenuity not disappoint. On April 19th, 2021, the helicopter made history when it completed its first powered and controlled flight on Mars. As a tech demo, Ingenuity was only designed to make 5 test flights over the course of 30 days. Yet it surpassed that by so much more. Over the course of nearly 3 years, Ingenuity would fly a total of 72 flights, traversing nearly 11 miles and reach as high as 78 feet. Here, we can see a map to all of the places Ingenuity flew to and landed. Ingenuity was outfitted with a small set of equipment that helped it navigate, fly, and overall be a tremendous scout for sites Perseverance might want to visit. It is powered by solar panels that charged batteries, has 2 very thin, rapidly spinning carbon fiber blades, legs that allowed it to land and sit properly on the ground, and sensors and avionics and cameras that helped the helicopter to take off, fly, and choose landing spots. However, on January 18th, 2024, the helicopter would take its final flight. During its landing, it came in such a way that the rotor blades made contact with the ground, and given how quickly they spin, there was just no real chance of surviving this. We later received pictures that at least 2 of the rotor blades were broken off near the tips, making flight no longer possible. The details of what caused this are still being investigated. But to me, this was still beyond a resounding success. Like the Wright brothers did here on Earth, the Ingenuity and Perseverance teams demonstrated our ability to fly on other worlds. And without their hard work and dedication, the helicopter would never have flown even once, let alone 72 times. Today, the Perseverance rover has traveled 17 miles and collected 25 samples for future study as it continues to traverse Jezero crater. The map seen here shows us each of its stops and where the samples were gathered. It also shows us the current location of the rover along with the final resting place of the helicopter. The dots we see show us a spot where the rover stopped. From here we can see that it makes many more stops than it does collect samples. This can be because what it investigated was not of interest, or due to limitations of how far the rover can go on each sol, among other things. We can be sure, though, that the team is selective about what samples it gathers. As with many things, I am quite excited to see what all Perseverance can learn and show us about Mars. The prospect of samples returning to us is incredible to me as well. All along, I have really enjoyed following the journeys of both Perseverance and Ingenuity. I am thinking about doing some follow-up videos in the future talking more about Mars as a planet and doing a deeper dive into some of the core samples the rover has gathered for us so far. If these or any other ideas seem interesting to you, please like and subscribe to my channel, and maybe even leave a comment below. I would love to chat with you all more there. If you are wanting more space exploration, check out this video here about the Hubble Space Telescope. And of course, let us all step outside tonight and look towards the stars.